Hello. Thank you for coming. I'm Lucia Moura. I'm a professor here at the University of Ottawa. For the ones that are in the CanaDAM conference, Canadian Discrete and Algorithmic Mathematics, you are back here again for another plenary talk, which happens to be a public interest talk. And we have the honor of having Po-Shen Loh here with us. And then we have many people that are not from the conference joining us, which is very nice. So without further delays, what I will do is ask the program chair of our conference, but not only that, you are a friend of Po-Shen, Sang-Il On, to say a few words before you start.
Right. Thank you. It's a great pleasure to introduce Po-Shen. I met him long time ago. He got a PhD from Princeton University under Benny Starkov on extremal and probabilistic combinatorics, some results. Yeah, that's the title. And then he's currently a professor at Carnegie Mellon University. And I met him at conferences like this. And then later, I met him more often at the International Math Olympiad, where I was coaching South Korean team, and he's coaching US team. And then in his website, he said, oh yeah, his team won the first prize in 2015, 16, 18, 19. And then I know why 2017 is missing there because of South Korean team. But that's when I was there. But anyway, and then later, so now he also founded a company called xp.com where he make problems with lots of good people and he will explain what he does. And also he's now giving a lot of public lectures, like even at the high schools. So this is 71st his public lecture of this year. In his website, you can see where he goes. 2 weeks ago, no, last week he was in London giving lectures in parliaments, and then he was in Washington, D.C. last weekend for 5 lectures, and he will be in China 3 days later giving another lectures. Okay, so, right. So please welcome Po-Shen.
Thank you. Well, hello. Thank you very much for the introduction. I actually have a lot of explaining to do to explain myself. You see, actually, I used to come to a lot of these conferences. In fact, I remember one of the last conferences I came to was probably about a decade ago. It was not very far from here, also in Canada. It was in Halifax. There was a Siam discrete math. Were any of you there? Yes. So there are a bunch of you there. In fact, coming to these conferences reminds me of how much fun it is to be around other mathematicians doing mathematics. The last conference I came to, well, that conference I came to, I even brought my kids. But time really has flown. Now that oldest kid is 18 years old and in her first year in college. So I've actually been off of this scene for about a decade. So I have a lot of explaining to do. What the heck have I been up to? Right. So this talk, preparing a public interest lecture is an interesting challenge because you have a combination of people in the audience. You have some people who are really crazy about math, so crazy about it that they choose to do it as their job. Then you got lots of other people from the general community, and last I checked, not everyone from the general community loves math. Although if you came here, you probably like it. But in any case, there's a general question. What the heck do these mathematicians do? All right, so this talk is designed to help people from the general public get an idea of what you could do with mathematics. And for people who are already mathematicians, to explain what I've been up to for the last decade. And maybe if you're ever interested in doing something that hits the real world pretty hard, I'll be telling you the story of what I actually did and how I went about doing it. First, let me start a bit with my background, because some of you know me, but not everyone. So I grew up in the United States of America, and I got really interested in math because of something called math competitions. And the only interesting thing about the math competitions is that they are weird questions. Okay, so the important thing is not about winning any math competitions, even though we talk about that sometimes, but I was leading the US Math Olympiad team, and I was really attracted to all that when I was a student because I got to work on questions where nobody had told me how to do them, and I would have to figure it out myself. I say this because even if you're not a researcher, if you want to work on weird problems, you can always find them in these math competitions or Martin Gardner puzzles, if you like those kinds of books. Anyway, that's how I got started. I did some math Olympiads and all that. And that taught me very much how to solve problems that other people had set, even weird questions. Then at some point, I started doing a PhD, and I had the great fortune of working with Benny Sudakov, who taught me how to take that problem-solving skill and move it towards advancing human knowledge. In fact, it was very inspiring for me to work with a professional, a PhD mathematics researcher to find out this is what you can really do. You can do more than just solve questions other people have given you. He told me one of the most important things is to figure out how to choose a question to solve. I still distinctly remember one meeting I had with one of our collaborators. I won't say who, but we were meeting with one of our collaborators, and the collaborator said, let's think about this problem. My PhD advisor, Benny Sudakov, asked, why should we? And the other person said, well, kind of interesting. We could think about it, and then afterwards we write something and see what everyone else thinks. My PhD advisor said, no. In business, first you find out what other people want to buy, then you make it. This is something I learned from him. Whenever you're going to put months and months or years and years of your life into something, figure out how you'd write the introduction before you start. And then if it looks interesting enough, then try to do it. So this has been actually very influential in my own life. Okay, well now let me tell you a bunch of stories that will go from that research part, which is when many of you saw me about 10 years ago, actively doing a lot of combinatorics research, in fact, and then I got sidetracked. I got sidetracked because I became the national coach of the US International Math Olympiad team. And I wanted to do that because I loved teaching, I loved sharing knowledge with more people, and I wanted to help the people who were like me before to try to take that path switch from solving questions other people gave you to maybe doing something bigger. And when I was being chosen for that role, I was actually interviewed by the person in charge, executive director of Mathematical Association of America. And I told them, if I take over, we will do worse. USA will do worse because I'm not going to focus on making sure that our team wins contests. In fact, I think that's detrimental to the mental health of the people who are playing. I want to focus on maximizing the chance that in 20 years I'll read about them in the New York Times. That's actually what I said. I said, I'll lead the US team in this way, and we'll see what happens. Well, we accidentally won. So I don't really use slides. I actually just show news articles and websites, okay? So we accidentally won. We were so unprepared for that we didn't have a photographer. So, okay, yeah, so this happened. But that taught me something. It taught me that occasionally news people talk to math people. That was my first experience talking to a lot of journalists about math, because you see, you've got to explain to the general journalist, why should anyone care about this? So I started to explain, the math helps you to think and all that. I was only at that point starting to solidify my way of explaining. Around that time, because I was the national coach of the US team, I didn't only want to mentor the strongest students for math contests either. I thought that was actually not inspiring. In fact, there's a story I always tell, and it's a great pleasure to tell this in front of Sang-il, who coached the South Koreans. I actually explained, in the past, a long time ago, I was an assistant coach for the US math team, and people would always ask me, how come China always wins and the United States always goes second? I said, well, look at the population. The population of China is 4 times the United States. If you think about probabilities and statistics, of course they'll win. Then one year, I think it was 2012, yes, 2012? Yeah, you guys won. And then I realized that my logic didn't make sense because the population of South Korea was very different than the United States in the other direction, okay? Then it occurred to me, I think what's relevant is not the total population. The question is how many people in the population are interested in learning and thinking and doing what? Whether they have to because their parents force them to, or whether they're innately interested, okay? So then I said, I want to find a way to get way, way, way more people in America and the whole world interested in math and good at math. Around that time, I also had some TEDx talk. If you find it, you'll hear I said, my goal is to build a more thinking world. At that time, I just thought, I liked math because it made me able to think clearer. I liked being around math people because they seemed like they thought about things. It would be nice if more people did. That was my early thoughts on this matter. They were not very well developed, but those were early thoughts. And so around that time also, in the United States, there was something that was blossoming. There was this whole ed tech revolution. There was Khan Academy. There was edX, there was Coursera, there were all of these things. So I started to think also, hey, maybe I should get involved with thinking about technology and mathematics, computer technology, internet technology. So because I work at Carnegie Mellon University, one of the greatest benefits of being there is you have access to really smart students who can write any computer program that you would want. So I started doing this with some students. And I got this idea, let's make a website where everyone can share their ways of explaining math, and we'll have people vote on what the best one is, sort of like Stack Overflow or Math Overflow, if you've heard of that. I said, let's make one for K-12 curriculum, specifically high school. We started doing it. And that's how I learned my first huge lesson. You first figure out what people want, and then you make it, not the other way around. It didn't work. It turns out that most people didn't want to submit explanations of how to do math. Or rather, there were some that did. They were like you guys. They explained it like, they geeked out like crazy, and the average human being, when they opened that thing, they said, what the heck are these people talking about? Okay, so this is, I'm just sharing with you, if you ever want to do anything with the real world is not really what's in this room right here. The real world is much bigger, and I met people who told me, if you ever want to do that, you got to learn to talk to real, normal people and find out what they want. So we started doing that, and we found out that most people actually just want to get their homework done. This was before ChatGPT. And so we did some user research, and we found out that the average high school student, if they don't know how to do a problem, they just type it into Google. So that's how I learned, okay, then what we should do is we should go and hire people who write in the same language and the same level as the people who are Googling, and then put the explanations up. And we won't crowdsource anymore, because the incentives for crowdsourcing don't work. I'm going to be talking a lot about incentives. I want this talk to let you see how you can start from something which is much more pure and maybe idealistic, and at some point hit like real world stuff, right? So I found out, let's get real people, and how do you incentivize them? You pay them. But who can we find? College students. Okay, that's the thing again. So right. So we started doing this thing, and it sort of worked. Let me see how it works here in Canada. I'm just going to search for how to subtract logs. What's this? AI overview. Oh, now everyone uses AI. But do you see what the top hit is? That's actually us. That was a designated strategy. It was that if you go and make the best, I hired people with the exact goal of make the best quick and dirty explanations of thousands and thousands of math and science topics. We did that. Now, unfortunately, the strategy doesn't work because AI overview is on top. Oh, well. But you see, it might make mistakes. So, okay, right. But anyway, so we did that. I consider that not very successful. At its peak, we would have about 300,000 visitors a month. Which is not much because the world has 7 billion people. So, okay, but we did get to 300,000 people a month. I did that for a while. As I was continuing to do this, I was also thinking very hard about how do you really get through and really get to the point of math? Because you see, I was also not super satisfied by this. Making people get snacks that are quick and dirty and aren't going deep, that's not fun. So as I was running around doing education, I would even try to teach young kids how to think about hard things. I still remember one summer in 2019, I started trying to explain to some 5th graders how to solve quadratic equations. And we derived the quadratic formula. I lost all of them. It didn't work. It turns out it's actually kind of hard to understand these concepts. Okay, well, I would always think about things. I actually thought about the quadratic formula, because that's one of the first times in mathematics education that you just memorize something. Do you know what I'm talking about? Like, yes, you might memorize half base times height is area of a triangle, but that's actually relatively easy. But negative b plus or minus the square root of b squared minus 4ac over 2a, that's a bit more of a mouthful. So I started thinking about that, and I accidentally came up with a simpler way to teach how to solve that. Okay, I threw it on the archive, and surprisingly, a month later, it got picked up by MIT Technology Review. And then it started flying everywhere. It got covered in the Daily Mail. Actually, it even made the New York Times. So this is something I learned. I learned that all the research I'd ever done before, the New York Times never covered. But quadratic equations, man! And it got 733 comments. Okay, so this is how I learned a lesson. Actually, I've recently been talking to this New York Times reporter about something else I came up with, an easier way to teach E. Unfortunately, that's not getting covered as easily. So quadratic equations, that's where it's at. Actually, this went so far around the world that I even got this thing showed up. This is PM Lee. This is Singapore. This is a mothership. I guess that's a Singaporean news. PM Lee nerds out with math professor on Facebook over a new way to solve quadratic equation. Math bros, okay? So this is Lee-Hsien Loong. So I should say, my parents are from Singapore. I myself did not grow up there. But I got really curious, who is this guy? Who is this Lee-Hsien Loong? And there's a whole article about this Lee-Hsien Loong and so on. I was reading the article. Okay, what is this? The media is funny. Fair to say that both of them had a nice nerd out session in the comments section. Okay, very nice, very nice. And then it turns out that PM Lee is pretty smart. So did anyone here attend Cambridge University? I'm a little curious. I actually also did. We all take a test. It's called Part 3 of Mathematical Tripost. We take a test. Senior Wrangler, what does that mean? That means you're the very, very, very top math student at Cambridge. Cambridge is a pretty famous university and pretty good at math. There was this guy called Isaac Newton who used to be there. But you know, actually, there's even a quote from... Now this is a fun audience to give this talk. How many people in this audience know who Bela Bolabash is? Whoa, let me say, it's a different question. How many of you were his PhD student? Were there any people here who were Bela Bolabash's PhD students? How can that be? Okay, how many were descendants of Bela Bolabash here? Okay, we got some, right? So he actually is a very prolific researcher who, there are many of his PhD students around. Right, but Prime Minister Lee is pretty good. He won by a street. Okay, so I thought this was very interesting. That was the first time in my life I learned that if you are a mathematician, you could be a head of state. Singapore is run pretty well, you know. Okay. Well, so this was all around the end of 2019, beginning 2020. And then suddenly my life took a very, very sharp turn. Because by around March 2020, I started thinking about very, very different things. Can anyone guess why? So there was something in the world called COVID, right? And the story here is I happen to already by that point have been playing with enough real world things to know how easy it is to make things that don't work. That makes you able to try to do things that do work, okay? So anyway, COVID was happening, and then I still remember on March 14th, 2020, I got an email. That day for us mathematicians is very easy to remember. March 14th, 2020. It has nothing to do with math, this email. This email came from a person from the Hertz Foundation community, which I happen to be part of. The Hertz Foundation is an organization which was started half a century ago in the United States, where they find about 15 people every year across science, technology, engineering, and occasionally math. And yeah, and if you get in, if you get in, they'll cover your 5 years of your PhD study with no strings attached. All right? Sorry, that's wrong. With big string attached, but without you having to teach, okay? The string attached is you agree, you make a moral commitment that if there's ever a moment of national emergency, you'll come to help. John Hertz, the founder of Hertz Foundation, was friends with a person named Edward Teller. Does anyone know who that is? Teller-Ulam model is the model of a hydrogen bomb. Right, so this is deeply connected to the Manhattan Project. So I happen to be one of these people. In fact, for the past few years, I was the director of the alumni reunion thing for our Hertz Foundation alumni. But so on March 14th, a whole lot of us got an email. And the email was from a person we deeply, deeply respect. And he's in the community. And he was sharing briefs about this new thing called COVID, saying this is very serious, very, very serious. It's going to do a big number on the world. And anyone who can put everything else down to go and do something about COVID, you should do this and remember to honor the agreement. You know, we all pledged that there's a moment of national emergency, this is international emergency. That guy I have a huge respect for because he was the guy who interviewed me and somehow made a bet on me. When I was being interviewed for this, he actually asked me, how is your math ever going to be useful? Because this is for the future Manhattan Project type stuff, right? So I said, well, you know, occasionally we have these things called error correcting codes. And I said a bunch of stuff, okay, which is actually related to stuff that we work on. Well, anyway, the email came in and I owe something to him. And anyway, we respect him a lot because he's this guy. What is this? What? Is it Bloomberg? I forgot which one it is. Yes, it is. My goal in life is to get a news written to me about me, something like this. This is about him, how an F student became America's most prolific inventor. Lowell Wood broke Edison's patent record and helped bring down the Soviet Union. If you get an article like that, you had a pretty interesting life. Okay, so anyway, I got this email from him and I started thinking, what can I do? Because I have committed to do something and this is international emergency. I had no idea what to do. Fortunately, the next day, March 15th, 2020, I had a PhD student who was graduating. And because, as you know, how many of you here are PhD students? How many of you here are PhD students? Okay, love it. You guys are PhD students. You will have to write a PhD thesis. Okay? And your PhD thesis will have to, it's basically all the stuff that you've done. You know, like my PhD thesis was some results or whatever, extremal probabilistic combinatorics. That's basically staple a bunch of papers together. But anyway, so you have to write this PhD thesis. And after you write your PhD thesis, you always give it to your PhD advisor to read. Do you know why? It's to make sure that there's at least one person on earth who ever read your thesis. So my PhD student, he gave me his things. I had to read them because he was going to graduate. I unfortunately only read one sentence. Those printouts are still on my desk because of the memory of like, this is what triggered it. I only read the first sentence of, I think, the 4th chapter. It was something like graphs. And I said, graphs? Graphs, networks. Graphs are the technical term for networks, which are things connected to things connected to things. How many people here in this room do research that involves anything involving graphs, even a little bit? Everyone who's not doing math or from the general public, look at this. This is graph. You're surrounded by graph theorists right now, okay? But what I'm going to talk about of what I ended up doing, deeply inspired by this graph theory, okay? So graph theory. I then suddenly thought, hey, this is the first pandemic that there are smartphones. I do graph theory research. There is a pandemic. Pandemic spreads on a graph. The graph is people who spend time with other people. Maybe we could try to figure out how to do this. And I work at Carnegie Mellon, where if you want to make anything, you can. Okay, so I dropped everything. I never finished reading the thesis. I will say no PhD students were harmed in this process. In fact, this is the first talk I've given where the PhD student is in the room right now. His name is Debsumya Chakraborty. He is awesome. He's back there. This is Debsumya. He's awesome. Actually, the reason that he's an amazing PhD student. Well, he's not anymore. He's a successful researcher now. But as a PhD student, he had to work with me. I was this guy who was always distracted working on everything else. Every paper you see with my name and his name on it, I didn't do anything. He did everything, right? He just came to my office with problems saying, I found this on the archive. Is this good? Good for you, right? He did everything. So if you want to hire anyone, he's pretty good. Okay. But anyway, so Debsumya, I've never given the talk with you in this room, but I've actually given this talk many times, and you're always the anonymous PhD student whose first sentence caused me to get off and start thinking about this. Okay, so I started thinking about this. Around that time, by the way, there was something called contact tracing apps. Singapore was the first country to roll these out. And the principle of those apps was that you'd have phones, and the phones would figure out if they were around each other, and maybe if someone got sick, you know the principle, right? They would tell you, oh no, you were around someone last week, and today that person reported positive. How many people in this room are familiar with that concept of an app? I think it was rolled out all over the world. Okay, Singapore was the first. So I thought, okay, well, let's go and try to make one. And I'm a technical guy, so we started geeking out over different ways you could do it. In fact, actually, fun fact, for one of the ways that we sensed whether phones were near each other is we actually used ultrasonic pings. Ultrasound just means sound that's too high of a frequency for you to hear. Turns out in order to make that work, you need to use sines and cosines. I never thought I'd use Fourier analysis in my real professional life, but on my team, I got a lot of good programmers, but I was the only guy who knew how to write Fourier transforms and real analysis with sines and cosines. So I learned how to code iOS web programming so that I could program the multi-core processor to be able to do fast sine and cosine processing. Even more fun. Actually, once we started making this, if you wanted to have lots of phones in the room all talking to each other, it turns out they can't just all be identified by their frequency. Because in physics, there's something called the Doppler effect. So if you're moving, the frequency is different. So in fact, in order to find a way for these phones to talk to each other, I had them sing songs to each other. I chose a few frequencies, key frequencies that we'd use to detect Doppler shift, and then we'd just try to see, is it this song or that song? I guess sort of like how dolphins sing, maybe? I don't know, I'm not a dolphin. But anyway, so in order to make this work, though, I had to figure out how to come up with songs that were somehow sufficiently different from each other. How many people in this room work on coding theory or design theory or any of those things? Do we have that at this conference? Yes, mad respect for you guys. I did my undergraduate at Caltech, and the person who taught me combinatorics was none other than Rick Wilson. So to me, this concept of, is it possible to make a lot of different songs that are somehow sufficiently different from each other? That's actually deeply related to coding theory. Anyway, we did all that. And after we did all that, we found out that, we have a fundamental problem. Because one of the good things is one of the first people to join my team to work with me was not a mathematician. Importantly, if you ever want to do real-world stuff, make sure you don't just surround yourself with mathematicians. He was a user experience designer. He kept asking over and over and over again, why would anyone want to use this app? We've just made the most precise tracking app. Okay, right. That's actually when we started to analyze this, and we ended up inventing a completely new way to fight pandemics. Because we were asking the right question, or rather he asked the right question, I was involved with coming up with a way to solve it. So we made a different kind of app. Our app would still keep track of which phones were around which phones. There are ways to do this without knowing where you are. You use these pairwise distances to figure out that these phones were nearby. You don't need the GPS location. And then what we did was different. First of all, in math, definitions are very important. Okay? So our definition of a connection or an edge between two devices, what that meant was different from every other app. What that meant was, over the last 2 weeks, there were at least 2 distinct 24-hour periods during which you were within 5 meters for at least 15 minutes. That's a mouthful. If you ever take a math class, you're used to handling these mouthfuls of definitions. So I'm going to say it again. 2 phones are connected to each other if, over the last 2 weeks, there were at least 2 different 24-hour periods that these phones were within 5 meters for at least 15 minutes. Now think about your own life. Who does that capture? Family. Friends. People you see regularly. It does not capture who you run into on the bus. Okay, this is very important. So that's our definition of our graph, of our network. Then what we did is we would tell you things like ping 3. Things like this. Somebody just reported sick, and they frequently spend time with someone who frequently spends 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 time with you. 3 away. Okay? At first, this sounds like not much of a difference, but let me show you what you can do with this kind of information. Let me see if I can pull up a very short video here. Does this work? Yeah, let's try this. What we did is we'd also show you how that changed over time. For example, yeah, let's start like this. Suppose you saw this. How would you understand this? This would mean that there's somebody who is there's someone who's 10 distance away from you who just reported sick. There's someone who's 11 distance away from you who just reported sick. And what does the 3 mean? There are 3 people who are 12 away from you who just reported sick. Okay? Then we'd show you how this changes over time. Like this is June 3rd, here's June 4th, here's June 5th, here's June 6th, here's June 7th, June 8th, June 9th. All right, suppose you saw this, and suppose there was some new disease running around called Ebola or some other thing you don't want. What would you do? Hunker down. And the most important thing is why? It's getting closer. And the important thing is, let's think about incentives. Why do you have an incentive to hunker down? Because you don't want to die. Wait, let's go and compare. Why did the other thing not work? The other thing, by the way, didn't work very well. Actually, in most of the Western world, people had the choice of whether they want to use these things or not, right? And if you have the choice and it just tells you, sorry, it's too late. You've already been around someone. Don't get anyone else sick. But no one will ever know that you were told to stay home. Unfortunately, people don't comply. The motivation before was with apps to help you not hurt anyone else after it might be too late for you. Ours was, do you just not want to die? It's optional. It's optional. This is the power of graph theory. For those mathematicians in the audience, I was just like, hey, just report the distance of the nearest infection along the graph theoretic metric. I just changed the metric space. For us mathematicians, we look at the world and we think about concepts. And usually you think about how close is something getting to you. Everyone else was using what's called the Euclidean metric. There was an app in India which would tell you, new person got sick and their house, their home address is 500 meters from yours. I have been to Mumbai before. Knowing that somebody else's house is within 500 meters of mine is not useful information. All right? But what is useful is this kind of a frequent relationship network. Okay, so actually I'm going to tell you more about this whole thing because this happens to be an audience which has a lot of math people in it. This is actually fun from many perspectives. One perspective is how in the world do you do the algorithm? if you actually want to efficiently calculate how many people are sick, have reported sick at these various distances from you, that algorithm could be quadratic or could be worse. If your n, the number of people you're dealing with, is very large, like 1 billion, it won't run in time. So we actually use something from the area of approximation algorithms. Is there anyone here who works on algorithms at all? Algorithms, yes? Right? Okay, I see there's a bunch of people. Approximation algorithms are algorithms where you tell people things which are not entirely correct, but close, okay? In particular, our numbers that we report are only correct up to about 10%. So we have made some mistakes in calculation. But we have a constraint, the thing that we protect, which is if anyone is sick at distance d, we will show you a blip with at least 1. So we have a guarantee that if there's a positive number of people sick at distance d from you, there will be a blip of at least 1. So it will show up. Furthermore, after that, however big the blip is, we'll tell you the answer within about 10%. As you can see, 10% of 2 doesn't leave much gap. And all the rest we put at 5+, because we know that for the general public, if you show an exponential curve going up like that, then it doesn't look very scary. You know what I mean? Like if this big wave from far away is coming to you, you're like, oh, there's only this itty-bitty thing coming down. No, that 1 is a real 1, guys. But we just max it at 5. So I'm just explaining that particular part. Having that mathematical background and knowing there existed things called approximation algorithms, that was useful. There's something else here. There's a deep incentive issue with making apps like this, and it's called no one reports that they were sick. How does the information get in anyway? There's a button called report that you're sick. All the other apps in the world, people said, surely they'll press the button. People are nice. I said, no, I don't think so. But that's because that was the only button they had. They had to tell you everyone will press the button or else their thing is useless. We had 2 buttons. One button says I'm sick. The other button says the contact tracers have told me that I was around someone who's sick. Okay, do you remember during the pandemic, everyone who got sick and got actually positively tested by the health authorities was asked, who were you around? Do you guys know this? This was called contact tracing, not with apps. It's really done. This is done every time you have dangerous diseases. Okay, now in our system, there are 2 kinds of errors. One kind of error is called false positive. One kind of error is called false negative. False positive error is easy to block. You just make it so people can only press the button if they're given a special code by that health authority, either for being actually sick or having been around someone who's sick. False positive needs to be blocked because otherwise people who don't want to do the test just report positive. I mean the math test, just report positive and close the school. Okay, so false positive must be blocked. False negative is the terrible problem because people might not press. But now on average, every person who was sick had about 5 contacts reported. So for every sick, we have 5 opportunities to get something in. Furthermore, people are more likely to gossip. Okay, but now how useful is the information anyway? If you found out that somebody who's 4 distance away from you pressed the button saying they're within 1 person, they're 1 person away from being sick. If you get information saying that 4 away from you, someone pressed a button saying they were around someone who's sick. How many of you have ever used the triangle inequality in your research? Has anyone ever used a triangle inequality in your paper? By the way, triangle inequality is absolute of a plus b is less than or equal to absolute a plus absolute b. What do I mean? If 4 away from you, there is somebody who's 1 away from a sick person, how far away might the sick person be? 3 to 5. Okay? Of course, there's a question, is everyone using the app? We'll get to that soon, okay? But if along the app network, hey, it's between 3 and 5. I realized I just built the equivalent of a signal amplifier. If you ever use a signal amplifier in electrical engineering, it makes the signal louder. But what do you pay for that? Like, what does it cost you? I don't mean money, but what do you lose? It gets fuzzy. Yeah? This is called the signal-to-noise ratio. This is electrical engineering. I don't know anything about that. But so what I did here is I said, okay, we can amplify 5x at the cost of a plus minus 1. Hey, that's not bad. That's still enough information for me to see that the wave is coming to me. This is how a mathematician thinks about these kinds of problems, right? I was like, that's just the triangle inequality. We're good. We add that second button. We can 5x the input signal. Now we're good. And you know what? What does it hurt me if in the end I only get like 30% of the hot signals? Because these things are infectious diseases. So if I only saw every bar 30% tall, but I see this whole thing coming towards me, I still have information. Does this make sense? I get to use statistics. I get to use law of large numbers. The problem with all the other apps was you only told, sorry, buddy, you were around someone who's sick. It's too late now. Do you see the difference here? When I realized all of this, I said, my gosh, I've never done anything in my life which might actually save people. I'm a math guy. Right? So nothing against math people. I'm saying this talk on purpose because all of you here are doing the kinds of things that actually could save people. And I realized I'm just going to go and make this thing get widely known. Oh, wow, that was an experience. I ended up spending a long time doing that because we came up with this idea within a few months, actually. And then I spent many, many more months getting the idea out. Because after I got the idea, I reached out to the media. I was like, we can tell people this new way. The media asked me, all right, what are your qualifications? Do you have a degree? I said, yes, I do have a degree. A degree in what? A PhD in what? Math. They said, no, you need to go and get a public health expert. You need to get someone who actually knows public health. So I said, okay, well, you know how to get a public health expert. You Google for public health experts. You see who's talking the most online. You send them emails. I was doing this. And I found out that if you email the most publicly active public health experts, they don't reply. Because they are also busy, right? There's this mathematical puzzle. If you ask people how many friends they have, the average number that anyway, so it's a fun mathematical puzzle. But the same concept is with this whole thing, it didn't work. So I decided to go back to graph theory. I had enough friends who do actual science. So then I just reached out to those friends and I would line up video calls. There was nothing else to do anyway during the pandemic. So I just caught up with those friends and I figured out how to make my pitch so that within about 5 minutes of explaining what this was to a normal scientist, usually the scientist would say, that's interesting. That's different from what everyone else has been doing. More people should know about it. Yes, thank you. And then I say, could you please introduce me to 3 of your friends who might be willing to get on a call with me? You know why I want 3? Because if you go with 3, one of them won't reply, okay? But if every call you have, you get 2 more calls, and then you get this, and then you get 8, I was building my own pandemic. It's called exponential growth. You just need the base to be bigger than 1, okay? So this is, again, as I was thinking through the whole thing, I said, that's what I'll do. By the way, the reason I was putting so much effort into this is because if you think about it, suppose there is a future pandemic. Suppose that the people who are somehow around the people, or around the people who got sick, what if they stay home? What would happen to the spread of the disease? If people somewhat related to the disease, wherever it was hitting, generally stayed home more, what would happen to the spread of the disease? That would reduce this R, right? And as long as that reduced less than 1, you'd be in good shape. So I realized that this would be another way to potentially stop pandemics from spreading, and you don't even need vaccines to exist in order for this to go. You just need to have tests. Okay, so that's when I said I got to get this thing widely known because this could potentially help us a lot. We're going to have more pandemics in this world. Right. So as I was reaching out, okay, so I managed to get through to the scientists and eventually at some point it reached into real like people working in public health. I never expected this, but I ended up giving talks at things like research group meetings at Harvard School of Public Health and meetings of real people. In fact, one of the most recent papers I published is in Public Health Reports, a journal of the CDC. I never thought this would happen in my entire life. Okay? But it was because we were just analyzing all of these, not analyzing, we were getting this word widely known. For those of you here who like graph theory, there's actually an interesting question in here, which I had a PhD student start working on, but then I got distracted. We ended up doing something else. But the question is, what density of people need to use the app in order for the signal to be useful? For those of you who are network theory experts, the fun part about this is that the graph is not the Erdős-Renyi GNP. The graph is not that everyone has an equal probability of spending time with someone from Kazakhstan as spending some time with their mom. Okay? In fact, there's something deeply geometrical about this. So in fact, these networks have a special type, which is that if 2 people if this connection is here and that connection is there, that intermediate connection is more likely to be present. There's an entire type of graphs of this kind of form. And it turns out that on those, if you don't need as high of a density of people using this app in order for the distances measured in that to be pretty close. You can think of this as if you had a bunch of friends and some of them aren't using, well, you could get through that way instead of that way. Did this sort of make sense? It's because it's somehow very, very interconnected. Okay, if you ever want to do a practical research problem, that actually is one. What happens on this kind of network? Of course, there is the point that, there's also the advantage. There is an advantage. The advantage is that you don't even need that everyone on average is using this. There are, of course, people who don't believe in stuff. And there are people who do. And if it makes it so that the people who do have enough people using it, that critical mass saves all of them. And the rest is natural selection. Oh, I should be nice. I should be nice. Okay, but in any case, the point is this is a technique that you can actually use to save yourself. All right. So one thing after another, we eventually got the public health people, and then the problem I ran into was the media still wouldn't cover it. The media said at this point in the pandemic, you need to have governments using it. So then I thought, oh no. Well, let's reach out to governments. And I reached out to governments, and what I found out was I got many people saying things like, well, it sounds very interesting, but how about you get another government to try this first? Man, that's mathematical induction without a base case. What that means is that you're trying to get something to work and you just don't get the first one and nothing happens. This, by the way, is why innovation is very hard, because everyone likes to follow, okay? And so I was thinking, where can I find some government person somewhere? I need someone who's actually smart enough to understand what this whole thing is, and also, like, you know, has enough power to do something in a country. Is there anyone I could possibly think of? The Prime Minister of Singapore. So I sent him an email, and I got an automatic reply because it got blocked. You know, they always have automatic replies. That didn't work. So I decided to follow him on Facebook and stalk him on social media. This is back to graph theory, okay? I was watching on social media. Everything I do in the world is like a graph. This is just how I think in my head. So I follow him on social media. And there was this one fateful day somewhere in September or October 2021 at this point. It was pretty deep in. And I saw that he posted something saying that, unfortunately, the Delta variant was now spreading wildly, and it was needing Singapore to do more controls. Singapore used to have they were on a zero COVID policy, very, very well controlled. And then suddenly this more infectious thing was going, and they had new policies. So I thought, you know, I'll try to comment on that. And I put this comment. I think I might have explained something about, you know, it's the graph theoretic distance, and somehow, you know, this is a way that uses game theory, it uses incentives to make it so that this is another way of controlling the pandemic. I posted it at 1 a.m. Central Time on a Saturday. I have a strange sleep schedule. But I was doing this at 1 a.m. Central Time on a Saturday. I actually was in Kansas City. I was giving a talk. And I went to bed because I've been working on this thing by that time for, I don't know, like 15 to 18 months. And always doesn't work. So you try your best, you go to sleep. I woke up the next morning and I found out, whoa, he replied. And it turns out that when the blue verified checkmark Facebook user replies to the post, replies to the comment on his own post, my comment ended up flying to the top. And then there were all these people from Singapore commenting on it. And then it got covered in the national newspaper of Singapore. Yeah, that was cool. So, oh yeah, and I try to keep my university happy. So, you know, you need to make sure this is here. This is how we keep peace. This is how we keep peace. I'm very fortunate that my department head put up with my crazy antics. My former department head is in this room right now, Tom Bowman. They somehow put up with me at Carnegie Mellon doing all kinds of weird stuff. But anyway, so this thing got in the national newspaper of Singapore. And actually one thing led to another. Then it got into the national newspaper of Australia, ABC News. At some point, it even got into the US News. And at one point, even somebody from the White House who worked on pandemic control reached out to me. It was the other way around now. Okay, so that was actually quite fun. This means that if in the next pandemic you notice that all of the apps around the world all tell you this like number of hops away, now you know where that came from. That was a year and a half of solid, like, come up with stuff, work. We worked 7 days a week. We were like just trying to get this thing through. We got it through. And then that made me slightly satisfied that maybe something I did in this life maybe could lead to like help for other people. Okay, but then I got bored. I got bored because at a certain point in the pandemic, people didn't want to fund more pandemic research like this. They wanted to fund more vaccine distribution research. I was talking to a funder who said they weren't going to fund us anymore because they heard that as soon as everyone gets 2 doses of the vaccine, the entire pandemic is over. Well, unfortunately, that wasn't true, but that's what happened to the funding. So, okay, we had to stop. I then decided to turn my way back to the education stuff because I've been doing that all before, and I really like giving talks. I like talking to people. I had been stuck at home, only giving remote talks. And then I realized, you know, actually, maybe I can just go on tour and start giving talks all around the United States. In fact, I wanted to give talks about this stuff because I wanted to spread the idea. There's only one problem. Holding a talk like this in 2021 is a good way to make a super spreader event, which would be kind of hypocritical, okay? But in the United States, how many of you are from the United States? I'm just curious, okay? United States, great. We have a tradition in the United States that you go to parks and you barbecue stuff. This is like a thing. There are barbecue grills in park. You bring your meat or your whatever, you grill it, okay? And if you have barbecue grills, do you know what else there has to be in the park? Picnic tables. And the picnic tables, therefore, need to have a roof on top of them because in case it rains, yeah? So I said, I got it. I'm just going to book parks, picnic shelters all around the United States and give talks. So I did. I started going all the way around. Let me see if I can find it. Oh, okay, I'll just jump to this one. This is what I did last year, for example, from January to August. That was January to August. If I can find, I won't be able to find a visual of the first year I did it, but it was something like that. This is a real-world example of the traveling salesperson problem. So, how many people here work on TSP or anything related to TSP? Okay, some, yeah. Okay, so of course, this is not exactly the traveling salesperson problem. I have to optimize for weird things like weekends have special benefits. So it's not actually a TSP at all. But the kinds of thinking of, how do you route all of this stuff? That's actually a combinatorial optimization problem. So anyway, so I did this kind of stuff. I traveled all around. And while doing so, I realized, there's something else that I can work on now. I'll work on a different pandemic. The different pandemic is people would like to, there are people who would like to learn more. And it would be great if lots and lots of people were good at thinking. This is actually what I started to see as I went from place to place. And then I moved off of pandemics because there was no more funding. I just decided to work on back to education. And while doing that, I came up with a new solution. And in fact, that's what the last part of this talk is. This is the actual work I work on today. I work on education again. See, what I decided to do is I said there's a lot of people who actually are quite curious, who would like to learn more. But not everyone has access to someone who can coach them on more. And also one of the best ages to start learning more is middle school, roughly ages 10 to 13. That is a time where you still have time in your life. You're still deciding what you care about. That's a great age to get into thinking. There's only one problem. How do I find enough people to coach them? Then I thought, I've worked with all these high schoolers because I was the coach of the national math team. So I know there's lots and lots of high schoolers in America who are actually pretty good at math. They're just too busy. What are they busy trying to do? Get into college. Extracurricular activities. They're trying to get into college. In America, if you want to get into college, you have to do all kinds of strange things. Community service, leadership. There were all these people I knew who were, they were running clubs. And the clubs usually had 3 people in them. A president, a vice president, and a secretary. And nobody did anything in the club, but they were all officers, right? So I knew that there was all this time wasting going on. And then what I realized was, actually, what these people really need, it's building the communication skills. In fact, actually, if you want to get into the famous US universities, it turns out it's not your resume, it's actually what your general communication ability is, both talking and listening. So I got a crazy idea. I said, let me start a program. We'll find high school students all around the US and the rest of the world who are clever at math and kind. I'll tell you more about why that's there later. Kind and clever. And then I hire professional comedians and actors to teach them how to be charismatic and electable. Okay, I'll say that again. I find kind and clever people who are high school students in the United States and the rest of the world. We got Canadians too. We have people from all over, okay? And once we find them, we hire professional comedians, actors to teach them how to be charismatic and electable. I'm able to do this because I work at Carnegie Mellon University. Does anyone know what is one of the hardest majors, if not the hardest major to get into at Carnegie Mellon? It is not computer science. It is our school of drama. We have one of the top drama schools in the entire country. If you're wondering why Carnegie has anything to do with performing arts, New York City has another building with Carnegie's name on it. It's called Carnegie Hall, and they don't do computer science there. All right? So I actually walked over to the drama department, and I said, can we work together maybe? Do you have any students or recent graduates who are looking for part-time paid remote work jobs? I was really ignorant. I thought this would be hard. It turns out that we could make win-win situations. And man, I love all of the performing arts people we get to work with. They are really inspiring. They are super talented. I have a lot of respect now for all of these people. One of our people who coaches these math people, he used to be a performer in Cirque du Soleil. He even worked for Steven Spielberg at some point in his career, and he also did some of the technology stuff some of the backstage stuff for Adele. He happens to be over 60, though. You don't perform in Cirque du Soleil when you're over 60. He just has decades and decades of experience. I've invented a retirement plan for performing artists. And they're good. Our high schoolers love them, right? We have another person. She's a dancer. She was a finalist for the Rockettes. That's a New York City. This is serious stuff. Okay, we were not able to get Margot Robbie, but you know, it's okay. You can't always. You don't need that. Okay, there's all these other people. So I was able to get enough of those. Just to let you know, the reason I thought of that is in part because earlier in my career, around 2018 or so, I took improvisational comedy classes. That's because I'd been working as the national coach of the US team to try to get more people interested in math. And I was funded by the Overdeck Family Foundation. John Overdeck is one of the co-founders of 2 Sigma. It's a very successful hedge fund. And so they paid for me to work with a professional public relations firm to try to get more people interested in math. And one of the first things the PR firm told me was they said, "We have a big problem. You are no good at talking to normal people. You only know how to talk to math people. You must take improvisational comedy classes." And so I spent an entire year, about 3 hours a week, taking improv comedy classes with normal people. It changed my life. For any of you who are teaching, strong recommendation, take improv comedy classes. You will never need to prepare for a lecture again in your life. It saves so much time. You just go in and you say, I forgot how to do this problem. What do you think? Because that's the best way to teach, by the way. That's how I teach. In my class, I say, I forgot what to do. PhD class, even better. I say, I forgot the theorem. I just know it's around something like this. What's false? Someone give me lots of counterexamples to something that might be true. And after we get all the counterexamples, I say, maybe then the truth is whatever is not that. Let's go try to prove it, everyone. I had a student once ask me, you have a very unique teaching style. Why doesn't anyone else use this? I said, well, I just didn't prepare for class. Okay, but so this improv comedy made a huge difference, and I said, if I could do this, I can get all kinds of other math people to get this skill too. That's how I got this idea. And the best part is if you really want to learn how to perform, you can't just watch Cirque du Soleil people, you can't just watch Rockettes people, you have to actually talk. Right? You got to practice by talking and saying something, these high schoolers. And what is literally the easiest thing for high school math people to talk about? Math. So the way they practice is by live streaming the best live video math classes ever made. I'm going to show you what that looks like. So I'm going to show you a 1-minute video clip, which has lots of 1 or 2 second segments all slapped together. These are all of pairs of high school students teaching math class to middle schoolers, okay? And I knew it would work. The reason is because even though Zoom class generally didn't work very well, right? I do online teaching. Zoom class, did it work well? Anyone who ever taught a Zoom class? How painful was that? That was horrible, okay? That was terrible. But I said there should be a way through, because the last I checked, all the kids are actually addicted to their screens anyway. So what if I just learned from them? Let me show you what we did. We made math class look like this. These are pairs of high schoolers teaching class, and this is lots of clips all put together. When you learn from them for a good hour with 2 people teaching.
Which means we're not playing videos.
Same thing as just adding 1 to n and then multiplying by 3.
The absolute differences will change.
Like, boom.
Equality between those 2 facts.
We do count as 2 separate things in the end.
Like, at least understand. We approve that.
Hi everyone.
And then we look, we say, okay.
You will get triple stars for that.
A really special thing about your city.
You use the exact same logic from over here.
Wait a second.
Or 1001. You can check it and let us know.
And I liked seeing that you guys were using your critical thinking.
We turned math class into a Twitch gaming stream. Does that make sense to anyone? If it doesn't, just ask your kids, okay? So we made math class look like Instagram Live. Oh, let me just stop this thing, still playing sound. Yeah, we made math class, let's stop that. Yeah, we made math class like what the kids are watching anyway. Actually, I didn't think of the colorful lights. The high schoolers told me. I just trust young people. They know what's true. They know what they like, okay? Oh, there's something else. Did you see how those people looked like pretty interesting? That's because we have an invention in there. I was the first person to come up with this idea that in every single classroom, we embed a professional actor. Those were not the actors. Those are the math people, okay? But here's how it works. We give all of our high schoolers 2 screens. One screen is that Zoom class, the thing that you all remember teaching over, the Zoom class. In that Zoom classroom, there is a professional actor. Their camera is off and their microphone is off. They're not disrupting the class at all. On screen number 2, there's a simultaneous second video call happening between the 2 high schoolers and the actor. In that one, they can see the actor, they can hear occasional tips, and they can see everything the actor types. Now what that means is if you teach for 1 hour, you get 1 hour of personalized coaching from a professional actor to make you more charismatic. Imagine if we got that while we were teaching, okay? Like imagine if as you were teaching, out of your like heads-up display, you got all these tips. It would be awesome. Okay, so no one ever did this before. I came up with this. It works. Actually, I know it works really well because my wife actually works with me on all of this stuff. She's the one who runs all of the actual classes. I'm the outside guy. She's the inside person. And over the last 2 or 3 years, every night she's been spending hours and hours with actors, and high schoolers. Man, over the last 2 or 3 years, she got really good at talking. It was awesome, okay? But it just rubs off. It just rubs off. So with this technique, I've suddenly invented something where if you are the high schooler, incentive-wise, you get something pretty powerful. When I was in high school as a math guy, I had no chance of talking to a Broadway quality actor or actress, focusing on me, trying to make me better. Suddenly, we have tons and tons of high schoolers all trying to join this thing. It even helps them with something that people really do care about in high school. It helps you get a date. I mean, this is just, and I have another goal with this, of course, is to make it so that more and more of us, people who decide to be mathematicians, we want to share, like, math is joyful, math is fun, math is human. We're all normal people, sort of. Yeah, we're all normal people, right? But I wanted to coach in this way, so we managed to make a win-win. All these people came in. Do you see how that is informed by my work on pandemics? In the pandemics and all the other stuff I did before, I was just making stuff I thought would work until I learned, let's figure out what people actually want. Then do it. Okay, so that's how that worked. By the way, at the same time, we also get to influence lots of middle school kids. We get to show them that it's fun. And that's when I thought, let's make sure they're kind too. Because around all this time, right? So let me tell you a few things that happened. The first is that CNN covered us. So that was not bad. Actually, I try to keep my university happy by trying to make sure there are articles every so often. But so CNN covered us, right? Yes. Carnegie Mellon University. Okay, right. So that was CNN. And then I started thinking about the rest of the world because I was traveling all around the world and I was thinking about AI. I was actually trying to think, how do I make this new ecosystem that I'm running create value in this world? In fact, just making people better at thinking is not really the target. In fact, I started thinking about AI because ChatGPT came around. And then I got the interest of the Wall Street Journal. They thought I was crazy. Carnegie Mellon University. Okay, they thought I was crazy. People have a strange opinion of me, but this writer is awesome. Actually, he eventually won an award for writing really, really funny articles. But so all of this stuff happened, and this also ended up getting the work I do even onto a bigger stage. Because no longer was I just going around telling people, hey, let's learn math. In fact, because of AI, we actually now need to update all of our education. Any of you who teach a class know that AI might be able to do your homework. And it can do my exams too. I don't even know if I can let students go to the bathroom during the test anymore. I make them give me a phone when they go to the bathroom. I have no proof that they don't have another one, okay? But this is just the reality of the situation. So the AI is making it so that we have to teach differently, but AI is also making me think about things from a much broader direction. I told you I was trying to make a more thinking world. That's what I said many years ago. Now I have a different way of encapsulating it. AI is going to hit the world so hard that it's going to be even more important that the people who are capable are using their knowledge to try to create value that helps people, or else we're going to have trouble. In fact, I started to move off into that philosophical direction. Who am I teaching? What do I want? Do I want lots of very smart people? I'm no longer satisfied with that. I actually want lots of kind and smart people. In fact, the way that I encapsulate that is I'm building a movement. I just put it this way. thoughtful. I used to say I wanted to build a more thinking world. Now it's actually what drives me. People ask me, what drives you? Why do you do all this stuff? I'm on a mission. I want to build a thoughtful world. I chose the way to spell this in a way, so it makes you think of the English word thoughtful, which is considerate, caring about others. But there's also a deep part here, should be very good at thinking. And I thought, if I want to get more people to be thoughtful, what do? You got to give examples. And so that's when I said, if I get all these high schoolers, let's get the most thoughtful ones. Let's have those people show the example that if you are really clever, actually you don't lord it over anyone. You're a nice person and you actually care. Of course, that's designed to cause its own virus, right? Because we have this exponential loop now. We have high schoolers live streaming to middle school students, helping more people see, the target to aspire to is to be really clever, but also have this very strong sense of humanity. This is actually what I'm after now, because I don't think that this world is going to get on so well soon if we don't tie everyone together. In fact, it's getting very polarized. To give you an idea of the kinds of things that I work on even right now, I mean, in the US, I live in a place where our university funding is in a little bit of trouble right now for some reason. Research funding, university, you know about this, right? And I'll tell you, like from my own experience, I had a wake up, an epiphany a few months ago when I was thinking to myself, why is it that there isn't more public funding support for mathematics, for engineering, for technology and all of this stuff? And I said, well, maybe I want to understand a little bit more about how everyone thinks. Because, by the way, public funding is money paid by the public taxpayer. So actually, the taxpayer needs to also think that this is going to directly help them. Okay. So I took my learning stuff and I started going to schools all over the country. In fact, I started spending a lot of my time going to rural schools. I went to rural Montana. I spent the last, 2 weeks ago, I was running through Tennessee and Oklahoma. In fact, my work nowadays is going into schools. And when I go into those, I'm not introduced as a former coach of the Math Olympiad team. I asked them to introduce me as, kids, you have a substitute teacher for today. His name is Mr. Po. That's it. I'm just going into school after school after school. Mr. Po, teaching math class, okay? The kids have no clue who I am. I know that it works because at least a couple times, students have asked me, have you graduated from college yet? Yes! The longer you can get that, the better, okay? But so I just go undercover, getting that idea. And man, I knew this would be true. Because you see, I grew up in Wisconsin. So I knew that there was lots and lots of brilliant people scattered all around the middle part of the country, not only the big cities. In fact, the epiphany I had a few months ago was, I do all this math teaching. We had people paying to take our classes. That's how we can keep this economically sustainable. We make the best math classes. People buy them. Great, we have money. I don't like paying taxes. So I spend the money giving away free classes. Then we have no profit. That's how it works. So then I just was giving away free classes. We gave free classes away in Baltimore, Miami, New York City. We were opening up free classes in Los Angeles. A few months ago, I looked at my whole profile. I said, okay, the people buying our classes are from the urban high-tech centers and so on. The people getting free classes are from the inner cities. It looks like I'm entirely exposed blue. Oh, wait a second. Outreach is supposed to mean outreach. How come my work is all going blue? How come I didn't realize before that there's all these other people? That's why I started going out into the middle of the country. And I'll tell you, the latest stuff that I'm doing with that is that, wow, I found so many super clever people in places all over the country where they they definitely would not have gotten the chance to engage in all of this math and science if not for the ability to have further coaching. So in fact, I'm using this entire infrastructure now where the goal is to try to mend in some small part the urban versus rural divide, the political situation in the United States, the thing that is costing possibly some of the funding. This is a root problem. How to make it so that people all around can participate. Because you know what? If you can't participate, why would you support it? And what I found out is that they faced a geometric problem. The schools are so far apart. They're small. It's hard to deliver all of those coaches. Man, I've solved it. So we're running through all of those regions now, offering all of this. Let me sum up. The goal of what I'm trying to do here, right? I'm trying to build this thoughtful world. I realized that in order to do this, we would need to have as many people as possible to be thoughtful. How to do that? Help to get young people to get interested. And also the older people, the high schoolers. How to make it so people who are thoughtful have a support network, a graph. Do you know why I have 2 people teaching every class? It's because the definition of a graph is a set of vertices and a set of pairs of vertices called edges. Okay, what that means is that these are networks. As my pairs of high schoolers teach together, they become good friends. We are networking together, thoughtful people from all over the world who bond over dealing with middle school kids. they're growing up. The goal is that as all these people grow up, they might do something. My hope is that people will use their skills to do something useful. One of the latest things that I shared with my high schoolers is the kinds of things that you can do if you do math. Like, for example, you could be the Pope. I mean, this is pretty interesting. I understand. One of my postdocs is here, Michael Tate, and he's at Villanova University. Where's Michael? You were here somewhere. Yeah, Michael said that the Pope was a member of Pi Mu Epsilon. That's a math society. Okay, so this is very interesting. And then talk about caring about people. That's one. And then of course the other thing I just shared over the last few days is this is pretty good. Romania, man, they just voted in the Cursor Dan. He, by the way, is remarkable. I've met him in person because he was at a math contest. I met him when he was a grown-up. But what is this? Where does it say his background? Yeah. This is an understatement. This is an understatement. He has 2 perfect scores at the International Math Olympiad. That's pretty good. But also, when I met him, I found out this guy, he has a combination of the smarts, and he actually cares about people, and he's also pretty good at talking. This, by the way, is what I'm trying to build. I'm trying to build more and more and more people who combine these idea of like something with public service. This is why hopefully it's useful to the public, right? Together with the brains to go and solve some problem, and the ability to talk, ability to inspire, right? I don't know what's going to happen in the world, but my only thought is, in this world where everything's getting more and more strange, hopefully, if we just get more thoughtful people, we can have a future. Thank you.
Is there any questions for Po-Shen? Or for Mr. Po?
Yeah, I'm just Mr. Po here. And I apologize for going too long. Yeah.
Thank you so much, Dr. Po. So I'm a proud mom of teenager who is sitting there. And it's really a whole kind of a new master degree for me to learn. So my question is, can you share some of your experience, your challenge, and your success of being a parent of a teenager?
Oh, yeah. Parent of teenager. This is tough. We have 3 kids. One is 18, one is 16, and one is 11. The 18-year-old talks to us again. It's great because she's in college, so she shares pictures. The 16-year-old has his own ideas. I mean, my main thing is I've worked with a lot of teenagers, and my advice to parents is limit how many commandments you give them. Like how many demands. The more demands, the harder it is. I just have one, actually. I tell my kids it's one. It's very simple. Be thoughtful. I'm actually serious. The advice I give them is just be thoughtful. What does thoughtful mean? Thoughtful means that, so okay, for me, what makes me happy is seeing other people smile. I like seeing other people be happy. I find it very addictive. I want my kids to have that, and also to have the ability to reason through things. So if you're thoughtful, I have nothing else I care about. This is perfectly honest. I'm one of these weird parents. I don't even know how to log into the system to see my kids' grades. That's not relevant. It's are you thoughtful or not? And if you're wondering, how can you measure thoughtful? Here's what I tell all the parents. If you want to get a sense of if your kid's on the right track, just ask yourself, would anybody marry them? That's it. That's it. Okay, so that's my advice. Okay, more questions. Actually, I just realized I forgot to show one slide, which is if you like these funny ideas, or if you want to collaborate, okay, I have 2 QR codes here. So one is every 2 weeks or so, I put out some funny ideas in the newsletter. That's an English language newsletter. This one is because I know there's people from all over the country and all over the world here. If you want me to come and give a talk at your place, or if you want to work together to help kids in your country, your city, or whatever to do well, I'm happy to collaborate. That's leave your email address or so into there. But yeah.
Thank you. Any other question? Careful. You hosted him for the whole Sunday, so you have the right.
Yeah. How do you assess kindness? I really like the idea, but how do you do that?
That's a good question. It's as hard as figuring out if you want to marry someone. They're comparable. Let me tell you the things that we use, okay? So we use several things, and we're not perfect. We have false positives and we have false negatives, all right? But we are able to statistically, what I'm interested in is statistically getting more kind people more empowered. Here's what we do. First, we ask them to write why they want to do this. We have this opportunity. Actually, we'll pay the high schooler, but not much. It's like $10 to $15 an hour. We don't want them doing it for the money. But then we want them to explain, why do they want to do this? That's one part. They might use ChatGPT, I don't know. But they explain why they want to do this. Then after that, we ask them for a teacher recommendation. The teacher recommendation, we don't ask any questions about their math ability. Instead, we ask very precise questions of how they deal with other people. Do they help other people? Do they seem authentic? Interestingly enough, in America, the teachers are honest. In America, the teachers will not say, this person is like an absolutely wonderful person, if they're not. Okay, statistically, right? Teachers will tick the box saying, yeah, not sure. So that happens. We also ask them a whole bunch of math questions, and we ask them to give us hints. That's a slight proxy for empathy. A good hint, as you know if you teach anyone, a good hint means that you've gotten into the head of who you're teaching and have some sense of what's hard for them. Okay, after all these things, then we ask for a 10-minute audition video of them explaining a particular question. It's very interesting. When you watch a video of someone talking, you can get a sense of whether they realize there's anyone else in the world who's ever going to watch that video. It's like, do they empathize with you? Do they care about you as the watcher? You get to find a lot of these little things. Actually, whenever I meet rich, famous people who I need to work with for whatever, if I've never met them before, I always check YouTube for their videos to get a sense of what kind of person this is. This is a strong recommendation. You can get a lot out of it, 10 minutes. Finally, 30-minute interview. And that interview is with two of us. And we talk to them about questions about life, what you want to do eventually, and so on. So this helps to have us select probably pretty good people. Then what really happens is then you get in, we teach you for about 20 hours how to teach people. Some people drop out at that point. They realize they don't want to do it. And then finally, they start teaching people. Then we found a great correlation. The people who do it longer generally are the kinder ones because they're able to put up with the kids. Did you know that putting up with middle schoolers can be a challenge? So now this builds in something wonderful. The longer you put up with this, the more charismatic you become. It's actually just directly aligned because every hour you teach, wow, look, one of our people now runs her own YouTube channel. It's amazing. But these are the dynamics that we put in. It's not perfect. We've made mistakes too. Yeah.
Would you be willing to share a little more about your ideas for opportunities for rural students?
Oh, yes. So opportunities for rural students. So let me just put this back to my slide here. So important detail is any of the rural schools that we're working with, we provide them with the opportunity that if they have people who are pretty interested in math, who are 6th grade, which is about 11 years old, then we can give them math classes 2 nights a week. This is a lot of math. All year round, we give them math. There are people in the world who want to do this. And what I found out as I went to rural school after rural school is there are actually a lot of people who want to do that. But I was not surprised because in Wisconsin, when I was growing up, the smartest math kid in my year was from a town of 1,000 people. And when I went to college, my roommate in college was from a town outside of Nashville with 20,000 people, and he was a super genius. Actually, he eventually became the vice president of propulsion at SpaceX. So I knew that there's this incredible ability in the rural parts of the country. And ironically, they could often go farther because there was less bureaucracy. It's actually pretty interesting. So to me, I noticed this. So then what we do is we say, hey, if you're crazy enough about math, we'll give you math taught like this from people who are super smart and nice, cohorts of about 25 kids all running together. In fact, my goal is to eventually have thousands of people running through this, building up this new entire cohort of all these people who are previously not engaging in this because they didn't have access, becoming amazing, and then eventually going to your universities and so on, helping to bridge all of these divides. We're able to do this because we attract so many high schoolers so we can deliver the units, and also because the classes that we made, people actually pay for. So we're able to finance this from the places where, did you know there are some parts of the world where people want their kids to be very smart? Did you know that they usually pay for it? We charge $23 an hour. It's actually cheaper. I invented a business model that is cheaper and better. It's from incentive alignment. It's a cheaper, better business model. Actually, we have enemies now. They're the people who run all the other math classes. After school math classes. Yeah, so then that's why I have the money. Actually, that's why I'm a little bit independent of the funding cuts in the US, because what we're doing is we're just saying, okay, great, thanks to Silicon Valley for buying our classes. Now we have money. I'm self-funding all of my research. Cool. Other questions?
Are we live? Now we are, yes. So it seems like at all stages there's a drop-off of participation of women in science, in all science disciplines. But I guess particularly it seems to happen right around the age group that you've been talking about targeting. Do you have any thoughts on how this could be addressed?
Yes. This is actually why we hit exactly that age group. That age group happens to be a magical age group where you decide what you want to do. It also happens to be one where people want to look and see, do I want to be that person that I see? Okay? Interestingly enough, when we're screening all of the high schoolers, we make zero effort to do any kind of special preference for one background or another. But we've noticed statistically that when the girls are applying, their chance of getting picked is ridiculously higher than the boys for some strange reason. We're screening for this combination of kindness and very smart, but not necessarily the absolute best in your school. Right? But what we want happens to have a lot of girls. This is a great opportunity because then we're making this entire internal thing. Actually, we found out more in our teaching style. Our teaching style is one where, actually, I heard this as feedback from somebody, where the mom said that her daughter talks a lot in our class because her daughter normally doesn't like to raise her. I don't mean to say only about girls, but like in general, people. The person doesn't like to raise their hand because they don't like everyone staring at them and what if they're wrong? Right? This is not just about girls. This is a general thing. In our system, did you see that the chat is on the screen, like a Twitch-style chat? So what we do is we systematically call on all the wrong ideas first. And then the instructors use the improvisational comedy techniques to say, oh, so you want to say the answer is 42? I'm so glad you thought of using 6 and 7. Those are the right numbers to use. Anyone have an idea of what else we should do with those numbers? It's called yes and. So we actually make it so that we systematically go from the least right to the most right, yes anding everyone. If someone's not talking, every classroom actually has 2 instructors, the 2 high schoolers, 1 actor, and 2 teaching assistants. The teaching assistants, this is a 5-person team. The teaching assistants are direct messaging everyone who's not talking, asking them, what do you think? What do you think? What do you think? This solves the problem of the kids not paying attention, okay? And once they say something, like if it's a reasonably good idea, the teaching assistant says, hey, share it with the big group. Okay, and then Robert shares the idea with the big group, and then the teaching assistants signal the instructors, call on Robert. The instructors call on Robert and say, Robert, I like your idea. No, not that way. Like, Robert, I like your idea. Would you like to share it? Robert shares the idea. They say, Robert, I'm so glad that you suggested this idea. Robert feels good, dopamine kick, So this is what we're doing. We're making it so if you're quiet, you just realize if you talk in this class, you can't go wrong. Like, the more you talk, the better you feel. This is actually how I teach my math class at Carnegie Mellon too, right? Like, no matter what you say, I'm going to yes and the darn thing. That's why we teach all the high schoolers improvisational comedy. Okay. And we hope that this will help. We hope this will help, the thing that you mentioned. Let's maybe do just one more question because we're over time, way over time.
Hi, thank you for your talk. I just had a question. So you seem to be encouraging young people to have all sorts of really big ideas about, thinking about the world more broadly. How can we solve these really big problems? But then in education, it seems like in undergrad, you spend a lot of time studying these very specific things, and then you go to grad school and you think about even narrower problems, and then you think about even narrower problems. And so how do you see those 2 worlds fitting together?
That's a good question. So I actually was just writing back to a Wall Street Journal writer about that exact topic a few minutes ago, like an hour ago or so. It was the same guy who wrote that article. He wrote to me again for some reason. But I actually think that we should all be thinking about what should we be doing with education, okay? Now, one good thing is that the university system, at least in America and probably in many other places, is one where you have plenty of free time to do weird stuff with your classmates. That's very valuable. I actually tell my students at Carnegie Mellon, don't fill up with classes. I told my daughter when she went to college, don't take too many classes. You need to make sure you have enough time to go and do all that exploration. It's a wonderful opportunity to be around people who are different from you, learn from them, do stuff together. So yes, there's things you're learning in the class, and there's things you can do outside. What's the value of all those narrow things? Well, actually, in what I just talked about in this talk, I ended up using a lot of what I learned that I never thought I'd use. Fourier analysis, sines and cosines, I never thought I'd do that, right? And all these different aspects, you just actually never quite know how those become useful. My style is I like to always be thinking about big questions, but I'm very, very curious about knowledge in general. So any chance I have to learn something from an expert, I actually want to sit down and listen. Advice, if you happen to be in school, just choose the classes in some sense based on whether or not there's a reputation that the professor is pretty enthusiastic and good at communicating the intuition. Then you'll learn stuff. Is it necessarily directly useful? I don't know. But you never know. And if nothing else, all of these, especially math, the value of the math major is it just makes you smarter. I'm serious. When my oldest daughter said she wanted to major in math, I said, this is great. I don't care. It's not going to hurt. There's no worry about job prospects. Because if you can handle lots and lots of backwards E's and upside down A's, chained one after the other in alternating format, and then you need to make a knot in front. Like, this is just like, in order to learn logic, it's actually, math is this crazy gymnastics for your thinking. If you do those hard problems, you get really good at looking at a complex problem and solving it. So I'm very enthusiastic that Romania's new president, man, that guy probably can solve those things. And fortunately, he cares about people, and like he has this people thing, right? To me, you need to have the both. So don't worry, the classes you're in, if it's math class, they'll teach you to be smarter. So that's useful. All the other classes, they probably teach you something useful too, right? This is true. They probably teach you something useful too. Any chance you can ever have to talk to someone who's an expert in their field, take it, right? You'll get something out of that. But just keep a big picture of like, what's out there? What might I do someday with my life? Good luck.
Thank you very much. Thank you, Paul. And thank you, everyone, for coming.